So 32 through 35 is kind of an interesting little thing, and I threw this in there because um, we need to know how to factor, and we need to be able to think about expressions. When I think about x squared minus 25, and I think about factoring, I think about a difference of perfect squares, and I immediately think x plus 5 times x minus 5. And my hope is that eventually you guys will get there with me. Some of you might already be there, but we're going to work on it. So when I see, if I saw something like 36x squared minus 49, I mean, difference of perfect squares, 6x plus 7, 6x minus 7. Because I know that whenever I multiply this out, I mean, they are conjugates, if you will, and I know the middle terms are cancel out, and I've got 6x times 6x is 36x squared, and positive 7 times negative 7 is negative 49. So when I solve this, or when I see something like that, I can just factor it immediately. It's a difference of perfect squares. Now these are sums. They're all positive. So if I thought about x squared plus 25, so let me think about x squared plus 25. If I were trying to solve for when that equals 0, I would end up subtracting the 25 over and then taking the square root. When you take the square root, there's two answers, plus and minus the square root of negative 25, which is in fact plus and minus 5i. If I were to solve x squared minus 25 equals 0, it's the same process. I add the 25 over, though. I take the square root, I got plus and minus the square root of 25, which is just plus and minus 5. So you might see the relationship between the factors, x plus 5, x minus 5, and the x equals plus and minus 5. Well, about the same token, if I've got x squared plus 25, the sum makes the factors imaginary, or the roots imaginary, if you set it equal to 0, the solutions. And so the factors are similar, it's just that it's an imaginary expression. So when I think about this, I know the first term is both going to be x. I've got plus and minus. I've got an I because it's imaginary. And all I got to do is think, well, what's the square root of 225? And the square root of 225 is 15. If I'm unsure of that, I'm going to set it equal to 0 and solve. X squared plus 225 equals 0. X squared equals a negative 225. X equals plus and minus the square root of negative 225, which is plus and minus 15i. So whenever I have these answers, these solutions, I can put them in my factors and be done. Okay? So part of it is just recognizing it as a sum of one, and not even necessarily perfect squares, but just, numbers. You can do it whatever you want, like this one. If I'm factoring, always look for a common factor, and I notice that they both have an x in them, so I'm going to factor that out, and then I've got x squared plus 19. Now, I'm going to write x times, in parentheses, x plus x minus. I know there's an I, because it's a plus, not a minus. And the question is what goes there, right there, right? So right here it was 15, because 15 is the square root of 225. Is there a square root of 19? Nope, not a whole number. So I'm just going to write the square root of 19 in its spot. And there it is. If I were to multiply that out, I would get x cubed plus 19x. And like I said, if I was unsure, I'm going to set this part, the quadratic, x squared plus 19 equal to 0. X squared equals a negative 19 when I subtract it over. X equals plus and minus the square root of negative 19, which is plus and minus the square root of 19i. Now, if you want to put the I in the front, that's perfectly fine. But that is my answer. Okay? On 34. Now, the number in the front that I see is an 8. What I want to do is I want to divide that out. If possible. I know I can, because 664 is divisible by 8 times, and 8 divided by 8 is 1, so that's an 81. If I was unsure, then I would have to, try 648 divided by 8. And if it didn't work out, then I would divide by 4 or 2 or whatever. So plus 81. Okay, so I've got 8. X plus x minus I, because of the sum, and the square root of 81 is 9. So 8 times x plus 9i times x minus 9i. And like I said, if I multiply that back out, I would get that, and I'll prove it to you right quick. I've got x times x, which is x squared. X times negative 9i, which is negative 9ix. 9i times x, which is a positive 9ix. And then 9i times negative 9i is a negative 81i squared, which is a positive 81. Those cancel out, x squared plus 81. Okay? So, number 35. Okay, 5 is a factor of 5 and 35, so I'm going to factor out of 5. And there is at least 2 x's in each. So I'm going to factor out of 5x squared. I'm left with the 5 is gone, x squared is gone, so I'm left with 2 x's. 35 divided by 5 is 7, and the x squared is gone. Okay, so this is similar to this one right here. 19 is a perfect square, all right? So, 19 is not a perfect square. 19 is prime, in fact, so it's just the square root of 19. So this one right here, I've got 5x times x plus the square root of 7i, x minus the square root of 7i. And that is my answer. Okay? Alright, that's the last I'm going to work on this review. The rest you need to do on your own. I will post the solutions, but I will not be working them out for you.